Hello, ladies and gentlemen. Today we're going to talk about how you can factor a polynomial when it shows up in what we would call a quadratic form. So what does that mean? You're going to kind of see this as you go, but it's something you want to recognize when you look at your polynomial before you start doing P's and Q's and any other things we talked about. If it looks like a quadratic, we're going to use something called U substitution in order to replace the power of x and make it so that it is a quadratic and we can factor it like normal, okay? What do you mean by that, Mr. Guy? Here's an example of what I'm talking about, okay? If I saw this polynomial, before I start doing P's and Q's and all that stuff, I'd look at it and say, you know what? This kind of looks a little bit like a quadratic. In fact, if I think of it in this way, what if I were to think of it as x squared to the second power? Think about your exponential as you multiply those, you get to the fourth, minus 3 times x squared plus 2. That kind of looks like a quadratic right there. A quadratic that maybe I could try to factor, maybe I know how to factor, okay? So how do we deal with that? Well, what we're going to do is we're going to go over here and we're going to say, hey, u is going to equal x squared. Okay? We say, all right, u is going to equal x squared. And then we substitute, we replace x squared with u so that this looks like a normal quadratic. And yes, I know, this is going to give us the immortal f of u, okay? I don't know why mathematicians decided to use u for this, but they did. So we're going to have u squared minus 3 times u plus 2. All right? And now when I look at it this way, I replace all my squareds with u's. Oh yeah, I know how to factor that. I can factor that no problem, right? So f of u is going to equal, and if we went through a factor, you can factor by grouping, or if you do guess and check, or if you want to factor, but it's going to be u minus 2 times u minus 1. Okay? Now that I have it factored, I'm going to go ahead and bring the x back in. So we're going to turn this back into f of x. And this is going to be x squared minus 2 times x squared minus 1. Hey, x squared minus 1, I can factor that. That's a difference of squares. I know that factor pattern. And so now I can rewrite this as x squared minus 2 times x plus 1 times x minus 1. Additionally, I know that x squared minus 2 is going to give me these complex roots. It's going to give me x squared minus 2 is going to give me these irrational roots, actually. So if I set that equal to 0, I'm going to find the following irrational roots, right? If I set this equal to 0, add 2 to both sides, I get x squared equals 2. So I'm going to get that x equals plus or minus the square root of 2. And I can use those as factors as well. So if I want to fully factor this polynomial, it is going to be x plus the square root of 2 times x minus the square root of 2 times x plus 1 times x minus 1. And there is a fully factored polynomial. Okay? Again, how did I do this? I recognize that, hey, this kind of looks like a quadratic. Normally, you'll be looking for either binomials or trinomials. And you'll look at them and say, do you know what? I think that this kind of looks like a quadratic. If I think of it as x squared, I can see that that's going to give me this kind of quadratic looking thing. I replace the x squared with a u. I do what's called u substitution, replace it with u's. I factor like normal, and then from there I put the x squared back in, and I kind of go through and do the rest of it as I would any other polynomial that we've talked about, right? Kind of look for either other factor patterns with your quadratics or kind of finding those roots and writing them out. Okay, so that's how we're going to use u substitution in order to factor these quadratics that show up in this factor pattern, this quadratic kind of look to them. All right, thank you all for watching.